Hello and good evening from Amsterdam. I'm Eduardo Lira with Team Convex Optimization. For those of you who remember, probably not too many given our view count, a few weeks ago we posted a video that said every week we'd post some aspect of our car, discuss something about it that we thought was special. That plan still exists, but we won't make the 1 week at a time deadline. Instead, we're going to be posting 2 or 3 videos a week, and we'll fill you all in before our race day, which is May 12th. So in this video, we're going to be discussing the high level idea of our car, which sort of sets the schedule for the next videos. So what you're looking at here is the Google development board, which focuses on-device ML products. So for those of you who are familiar, Google has its tensor processing units, which handle their tensor applications for machine learning very efficiently and very well. So being able to run machine learning for a driving task, which is inherently a complex task, very hard to describe iteratively through rules or whatever kind of classification you want to use, doing that through machine learning and letting a machine learning model, specifically a reinforcement learning model, handle that would be a great idea. It didn't work out for this year for quite a few reasons, which we'll discuss in later videos, but I want to keep these videos nice and short and concise. So we're running this Google development board, which has NXP IMX 8M SoC running Linux on ARM, and Linux should be very familiar to you all. Now, this makes quite a good coincidence, because Linux is running on the car, Linux is running on my desktop. Why is this good? Well, if I'm driving the car with Linux, so let's say I can emulate everything as different tasks, different processes, have a task for segmenting images, one for deciding where images go, deciding where to put or where in the image I should be, deciding how to actuate on hardware. That's indivisible to the car or to my desktop. So what if I were to make several processes, some simulator specific and others car specific, so that I can run my segmentation, image processing, and decisions, driving decisions, independently either in the simulator or in the car. And that's exactly what we did. So here's kind of a high level layout of what's happening in our car. These bold, large text are processes. This green box here is what's happening specifically in the simulator. This is specifically in the car. These two happen regardless, and these are shared memory structs. So everything's on Linux, everything. All these processes, they write to shared memory for inter-process communication. We let Linux handle their scheduling, their memory management, how they handle locks, etc. And we just have this control daemon, this planning daemon. Um, they handle how to drive the car. So the planning daemon takes an image, segments it, and decides where the best place is to be through, vectors, line scans, ray beams, you name it, we've tried it all. And the control daemon says, hey, given where the car wants to be and my current state, so given the sensors, so how fast am I going with my current steering angle, how should I actuate on that? Specifically, this is a PID, but we'll discuss that in a later video. So this is quite a nice way to model things, right? So the planning daemon says, hey, I get an image, which either happens through a camera or an image in the simulator. It segments it, processes it, decides where it's to go. The control daemon reads this, says, oh, you should actuate as so give 75% throttle and 40% steering to the right. And that's written to this control struct, which either the simulator will handle or the car will handle. So let's see what that actually looks like, right? So I said we built a simulator, which has some obvious benefits, right? I'm going to go on a tangent here again. I'm not going to show you just yet. I'm going to hold you a little bit longer. So building a simulator, we can all work on the car at the same time. We can work on it at home. We don't have to worry about batteries. We don't have to worry about things breaking. And we can test ideas and see what works best and only apply the most favorable solutions to the real car, given that, well, batteries, things, hardware, they're expensive. So let's see exactly what that looks like. I should be able to switch to this frame here. I should be able to open this and this. Now, here we're looking at, this is a planning daemon which segments an image and we draw our segmented image and we can draw beams, rays, boxes, etc. This is a simulator which is driving through shared memory and it's driving our car for us. Now, what you see here would be exactly what would happen, or as much as physics is modeled, what would happen on the real car. So we segment this image. This is actually what the image looks like in the real car in shared memory. Then we cast some beams left and right, and we have some perpendicular line in this case, handling throttle, and some PID, which is a process, of course, you can't see, it's just happening. It's reading this struct and deciding how to actuate the car. So hopefully this gives you a high-level idea of how the car works and why we made it the way it's made. So the key takeaways are the car is built in Linux. It's built on this Google Coral board, which should handle machine learning. We built a simulator to first try reinforcement learning and then put down to the car. That didn't work. We'll make a video on why. And we, by consequence, had a simulator that we could then try to, or we could experiment with the car. So we could visualize frames and we can control them on a simulator so we can all work at the same time, try whatever ridiculous things we want to try without risking breaking the car or exhausting batteries, having to charge batteries, etc. Leave in the comments down below what you thought about this video. Next time we'll be talking about the planning daemon or the simulator. We'll see whichever one we make first. And we discuss or we intend to make a video for each of these processes and then some more to fill in some gaps that there may be. So thank you very much for attending. Leave in the comments what you think. Let me know if you have any questions. If you think that this is a great thing, if you think this is a bad thing, just let us know. And I'll see you guys next time.